Hi class, I will now introduce you to the concept of weight. At the end of the lesson, you should be able to describe weight as the gravitational force that acts on an object, W equal to mg. Most of us think that mass and weight are pretty much the same thing. Are they? No, they are not the same thing. Mass is defined as the amount of matter present in the object. Now consider these two situations. For the first situation, the object is on the earth. And then for the second situation, the same object is on the moon. Will the mass be different in these two situations? To answer this question, you can ask yourself whether the amount of matter present in the object be different. Absolutely not, right? The amount of matter in the object is not changing at all. That's why the mass will be the same for both situations. Thus, the mass of the object remains constant no matter where the object is. Besides that, mass is a scalar quantity that has magnitude only. The SI unit for mass is kg. You have learned in previous lesson that mass is related to inertia. The relationship between mass and inertia is the greater the mass, the greater the inertia. If mass is defined as the amount of matter present in the object, then what is weight? Weight is the measure of how strong the gravitational force acting on an object. Thus, weight is defined as the gravitational force acting on an object. The weight of an object, or the gravitational force acting on an object, depends on gravitational field strength. The symbol for gravitational field strength is G. Gravitational field strength is defined as the force acting per unit mass caused by gravitational pull, or gravitational force per unit mass. On the surface of the Earth, the average value of gravitational field strength is 9.81 Newton per kg. It means that object with mass of 1 kg experiences 9.81 Newton of gravitational force. Thus, the weight is 9.81 Newton. Object with mass of 2 kg will experience 2 times 9.81, which is equal to 19.62 Newton of gravitational force. Thus, the weight is 19.62 Newton. Gravitational field strength on the moon is 1/6 of the gravitational field strength on the Earth. Thus, the gravitational field strength on the moon is 1.635 Newton per kg. This means that object with mass of 1 kg experiences a gravitational force of 1.635 Newton. Thus, its weight is 1.635 Newton. Object with mass of 2 kg will experience 2 times 1.635, which is equal to 3.27 Newton of gravitational force. Thus, the weight is 3.27 Newton. From the example given, you can find that weight is equal to mass times gravitational field strength. Thus, W equal to mg. We also can derive the formula of weight based on Newton's second law of motion. According to Newton's second law of motion, force is equal to mass times acceleration. As we know, when an object is dropped, it accelerates towards the center of the Earth. If air resistance is negligible, the net force that is acting on the object is the gravitational force, or the weight. Thus, the F is W. You have learned in previous lesson the acceleration of a free-falling object caused by gravitational force is known as gravitational acceleration G. The average value of Earth's gravitational acceleration is 9.81 meter per second per second. It is the same as the value of gravitational field strength. So we get weight W equal to mg. As a conclusion, the weight of the object is not a constant. The weight depends on gravitational field strength. Weight is a vector quantity, means that weight has both magnitude and direction. The direction of the weight is the same as the gravitational force, that is, towards the center of Earth. The SI unit for weight is Newton because weight is a force. If the gravitational field strength is constant, then the greater the mass, the greater the weight.